The other conferences that I've attended, I would say that they've been pretty straightforward, where you attend the talk and then it's kind of over, you take a break, and then you go to the next talk. What's really unique about CppCon is the fact that after the talk is done, it's welcome and encouraged to engage in dialogue with both the presenters and other attendees.
Hello, good afternoon, everybody. I'm the last thing that hinders you before Matt's talk. My name is Tesch. When I don't fly a Starship, which is sadly most of the time, I teach C++ mostly. Also something new about retro console programming, because that's my thing. If you need to reach out to me, all my information is there, you can look it up. Here's some branding from the school I work for, as well as the Belgian C++ user group, which is great. This is kind of a continuation of a speech I gave last year, a talk I gave last year. So if some of the things I say seem weird, go see my previous one. I'll give you a short rehearsal. Why should you care about writing a GameBoy emulator, and specifically one that can run Tetris? I will explain this in one slide. If it's good enough for them, it's good enough for us. So, seriously, why did we start this project? This is our goal as teachers. What? Seeing the world burn? That's what the students think, but no. We want to light a fire. I cannot teach anyone. All I can do is try to convince them to do stuff. But to convince people that stuff is cool and that they can learn a lot and that they should learn a lot, I need to know stuff myself. To know stuff myself, I also need to do stuff. Great. So, as a teacher, what options do I have? Well, there's the tiny little programs we write for our slides. And then, of course, I see a lot of code. I see code from my students. That's also not ideal. So a couple of years ago, I decided I'm going to do a relatively large project so I can keep up to date with modern techniques and not just talk about it, but do something. And I picked an emulator. I didn't really know why I picked it, but somebody at this conference gave me the reason without me knowing it. When you're building an emulator, you can play games and pretend you're working. Yay. So yeah, pretending to work, that's what we teachers do. So I wanted to do a project called the Teaglon. And Teaglon was a backronym for Tetris for Game Boy, Logic, and Version. Does anybody know where the name Teaglon comes from? No one. You should all read more science fiction. Yes, Koen knows, because I told him. Koen is my colleague, who is also here today. So this is a sped up.
Where does it go from?
Yeah, leave you hanging. Come talk to me afterwards. Give me a sticker. So this is just somebody playing Tetris 20 times speed. The question I'm wondering is, if I have the end screen, can I run it backwards and know what buttons I need to press to get there? Can I do that? Well, it's deterministic, right? There's no random in Tetris and on the Game Boy. But there's no way to calculate backwards. So to do it, I would need a lot of computing power and calculate forward a lot and explore the possible paths. Also, Tetris, it's well researched. There's an amazing amount of real scientific study about Tetris. It's proven to be NP hard. So Tetris. Also, more technical reason, it's super tiny, 32 kilobytes, no memory bank controller, it just fits right into your Game Boy. You can access anything without special stuff. So all this I told last year, this fantastic Teaglon project on which I was gonna work on half-time, got refused because that's how these things go. Still a bit bitter about this. But I needed to have a whole bunch of people that supported me in doing this, from the industry, from academia. So when it got refused and I still got a talk out of it, I sent them all a mail. You don't have to read the details. Basically, I said, hey, I was right, it's cool. I did talk at CppCon. Interestingly, I got a mail back. Hey, it's inspiring. I've also tried writing my own GameBoy emulator, which is cool. Remember, my job is lighting a fire. I can teach you stuff. I'm not smart enough for that. Just make you enthusiastic about things. And then later he sent me a mail. Hey, you can look at the thing. I actually wrote it in the best language there is. It's called C++. Not C, C++. Right? He talks about it here. Work, damn it. C++. And he says, yeah, it's just C, but enhanced with a bit of stud vector. But like any good programmers, he understates his skills. Just so we... any good programmer. Some of us have hubris, that's something else. So just so everybody knows what's going on, I'm going to do a live demo because those always work well. Nothing ever goes wrong on a live demo. Like this. And then I can pick this. Yes, increase the font a little bit. Okay. Wait, yay, it works. It's fantastic. Even the buttons work. I can use these or my keyboard. It also makes sound. Don't worry, you all know the sound is not important. So you can play this. And this is all great. Yes, I'm not a very good player. What's the point of this game again? Okay, let's start again. Let's start again. But now I'm passing a parameter called record. There we go. Now it gets recorded, so I have to try a bit better. Let's go. Yeah, it's a better. It's not that important that I do well, though this is the most stressing part, playing Tetris while people are watching you. There's a reason I keep playing, by the way. The recording should stop auto-magically after 2 minutes. As you can hear, the audio has a couple of frames of delay. If you can hear it, that's because the guy who wrote this, Olivier, chose Qt to do it. If all you have is a hammer, all your problems look like nails. Okay. Is it 2 minutes already? Is somebody timing this? It must be about that. Just imagine that it doesn't stop anymore. That would be terrible. Don't worry, I have a backup. I have recordings. Oh, come on. It's still not stopping. It feels like 2 minutes already. It feels like an eternity, actually. It's like a world championship of Tetris. I think I will just give up. Ah, there it goes. 2 minutes is long when you're waiting for it. Okay. So it saves just my button presses. There's a little counter that's linked to the internal clock of the Game Boy, and just logs at what point in that counter have the buttons changed. I can then, of course, do something called replay. This is super cool. Look, it goes much faster. Bam. There we go. It's not optimized for speed, but it's still 22 times faster than real time. So that's about what we get out of this. It's not optimized for being the fastest thing. So that's what Olivier wrote. Cool. Let me go back to PowerPoint. Probably have to. Just love switching between sharing mode and PowerPoint. That also goes right all the time. So I decided to look at this project because you learn a lot from looking at somebody's project. This was done on GitLab. I'm used to GitHub. I've never done it before. It's okay. I like it. It's the same, right? I have no strong opinion. There's 13 CPP files, 12 HPP files, and 2 .h files. Thanks, Qt. The original GitLab link is there. I have an own fork about which I will tell a bit. I like that it's HPP. There's some other people in the audience that like that. If you disagree, go listen to his arguments. He's right. What's happening? Okay. So I usually work on Windows. I also usually use Visual Studio projects. This is a project made for Linux, and it uses CMake. So I was like, oh, I'm going to do that with WSL. I've never done a lot with that, and I want to debug it in Visual Studio. What could possibly go wrong? It's a very expensive piece of software made by one of the biggest software companies in the world. It's probably perfect. Yeah, no, turns out that the WSL is not Linux. So these are the changes I had to make to the CMakeless file just to get it to compile and run. It's to do with threading. It's on WSL Debian, I need this. On Debian, at Olivier's place, it works without this. I have heard several reasons why this is, but none of them can solve it. So, but I mean, this CMake file works. So if you want to work on WSL on Linux, use my GitLab. This conference has been a lot about AI. AI is cool and it's the future and it's PhD level intelligence. Well, I have a license for Enterprise Visual Studio. I'll focus on what it told me. What you can do is run from the terminal or try Visual Studio Code. That's what the Copilot inside Visual Studio Enterprise tells me. It's PhD level intelligence is telling me you're wasting your money, man, and I cannot get it to work. By the way, when it starts its talk with, thank you for your honest feedback, that's because I was cursing at it. So another advantage, if you start on somebody else's project, you learn a lot about tiny tools they use and make their lives handier. I didn't know Plant UML to make these beautiful UML drawings. It's very convenient. I don't use UML when I'm designing software, but it's very convenient when you're trying to understand somebody else's project. Oh, by the way, before I forget, my friends at Nintendo, if you are watching, look, these are my Tetris cartridges. This is the tool I use to dump the ROMs onto my computer, so I'm legally allowed to play my own software. Thank you. Don't sue me, please. With that same tool, you can make beautiful timing diagrams. I actually like these a lot. So that's great. Okay. Awesome. What else can you learn from somebody else's projects? Well, you can learn about the libraries they use. Qt. Yes, I would also develop games in Qt. One of the happiest things I heard, and I hear it differently than what it says. I just heard C++26 reflection is gonna make Qt go away. I have no technical reasons not to like it. I just don't like it. The whole MOC system rubs me the wrong way. Good. And you see, I skipped a bit. I'm not going to talk about coding style. I'm going to talk about license first. My colleague is looking at me weirdly. Tom, have you gone corporate? Are you going to start talking about licenses? Yes, but this is one I like. I hadn't heard about this one. The beerware license. All my software will be beerware license from now on. So if you like the software, you find it useful, you meet the guy who wrote it, buy him a beer. It's perfect. Perfection in a license. So a part of this I hadn't told you. This Olivier guy, he doesn't live too far away from me. We're only an hour and a half drive. So of course, what did we do? So very, very important. You see, Nintendo, I adhere to the licenses. So now about the coding style. He calls his coding style C++. And I told him, look, I've looked at your code, and it's well-written code. Right? We try to promote modern C++, and modern C++ is great. It's fantastic. But you can still write using crummy C++ fantastic code. You're just not as well protected. And so he calls it C++, not C++, otherwise that would make Bjarne very mad. And he says it's C enhanced with the C++ stud vector. Why does he do that? I'm going to go on a tangent here and show you a wonderful picture. Look, this picture was taken in 1987. That's me. And that's him. We were in the last year of primary then. That means we finished our formal education to become engineers before 2000. That's the period where we officially learned C++. 11 years before the 2011 standard came out. Cannot blame someone for not knowing this. So what can we do? Well, I'm lucky, I'm in education, I have a lot of time to study. Some people have written great books about C++ and how you should write good C++. I have actually brought mine. Another plug. Mine is better than anyone's because it's signed by the two authors. The advantage of speaking on conferences is that you can get several people. The other is by Rainer. It's also excellent. Right? It talks about the ISO C++ core guidelines. So this Olivier guy, he's way too humble. Doesn't he? He just uses C and stud vector. No, he uses C++ 98 and stud function because, like everybody, he hates to write function pointers in C style. He uses stud array because it's great. Stud vector, stud runtime error, uses a lot of lambdas. He actually weirdly uses shared pointer and make shared as well. Stud thread, things to make this thread sleep. Stud chrono, stud bind and placeholders. That's terrible. To string, some I/O manipulators, file system, and uniform initialization. Also not systematically, but a lot. You can learn a lot by looking at an application at the main. This is his main. Now, this isn't the best code in that code base. And why is that? To him, the final product is the library. And that's why it's called GameBoy UI. He just wrote a little UI with it to just be able to play around with it. So, that's the code it is. Before we go any further, because the goal of this talk is that we're going to analyze this code and try to improve it a bit. Depending on how much time we have, we can look in more or less detail. So let's set up some ground rules. What I want to know is if I have code that works, if I do change it, right? If I do change it so it adheres to modern C++ rules, will it improve? And how will I know, right? So no change in the basic structures. We're going to use C++20 because that works. The project as it was ran C++17, so that's a small improvement. We will not add additional features or additional safety. So as an example, let's take a look at the main. What can we do? Well, if we use a span, we can improve that for a bit. And then with the string view, improve how we can check these things. As you see, this improvement actually made the code longer, but I would argue that it's better. Oh, also I have to say, before I went to the whole process, I took his original code and did it in Google indentation style. Why do I use Google indentation style? It works well on slides. And I ported his to that, so if we compare the results afterwards, lines of code, it's transferable. Oh, we're talking about raw loops. This is one I've heard repeated a lot. It was started by Sean, I think. That's the earliest source I found from 2013, right? No raw loops. If you do one thing for quality, no raw loops. So I was like, ha, that's what I'm going to do. Suck at C++, I'm going to look through this whole code base, find all the raw loops, and replace them. Sadly, almost all the loops were already ranged forwards. So far for the guy who says, oh, I just do some C with std vector, right? So it's not really sadly, but there's still room for smart use of algorithms in some of the forks he uses, but if you're doing that, are you changing the architecture? You're skirting on the, so I'm not going to do that. There were only 7 raw for loops left, and the only quick way to improve them was by using IOTA. That wasn't tremendously good. There were no big wins there. So what changes did we do? Got rid of all the raw loops with IOTA. This is the stats, right? 2 files were changed, 12 insertions, 12 deletions. Nah, not much happened. I was thinking, what's an easy one? Because you're looking at the code. The code base is 4,000 lines of code. You have to look through it. Oh, I know, enums. I'll replace all the enums with enum classes. That's a good one. Let's do that. I tried it. That was a bit more work, also a bit more interesting. It was 138 insertions and 108 deletions. But then you discover it's the little things you miss. Stud2 underlying, I like that. That's so convenient. And instead of having to do all these static casts with stud2 underlying, you can just pick the value out of there. I had to do a lot of static casting, which means it's probably not a good design to use enums there. If you're not using enum classes, then it doesn't really matter. It's another way of defining constants. You can just use them as numbers anyway. So there's further room for improvement. So a lot of static cast was involved. Showed we missed some abstractions somewhere. And we were not going to make architectural changes, so we're keeping as much as we can, just changing the basic. Just changing the basics, static cast. That gave me inspiration for the next thing. Ooh, let's use curly brace initialization as much as possible. That's a good one. That's also a weird one. I use curly brace initialization everywhere. If you look at the ISO core guidelines, and all the examples they don't use it anywhere. Everybody writes int integer index equals 7, not curly braces 7. You could, it would be safer, nobody does. But I did it, right? I went to the code, did that. I think I found most of them. I'm not 100% sure. Okay. I found some new and deletes. That's cool. Again, that's weird for a code base that's supposed to be C. It's std vector. But new and delete was used. I replaced it with unique pointers, of course. That was actually a pretty small change that went very smoothly. Quick question. I found 50 news and 11 deletes. Is that a problem? Who says yes? Raise your hand. It's hard to tell, and the answer is no, it wasn't. There was a bunch of news in the switch, and depending on the states, another object got started. And since it was polymorphic, you only needed one delete. So it wasn't a problem. But you're all very smart C++ people, and you hesitated. With unique pointer, you don't have to hesitate. You know it's going to be correct. It doesn't have to be a problem. While I was investigating that, I also found 2 shared pointers. What? Shared pointers. That's not something I was expecting. So further changes, I decided to remove those. Wasn't that very hard? No, it wasn't. Again, the book I referred to earlier, written by Guy and Kate, he tells you, and it's a required book for my students, if you're using a shared pointer, you're probably missing some kind of abstraction. Yeah. So if I had to change the architecture, I would not change it. But I didn't have to. I can show you the code. So it had to do with the recording. He creates this recording object and then passes it on to the clock. Why is this recording and replay object in the clock? Because it clocks in the clock, it counts the ticks and then records what happens, and he has to create it somewhere else so he can pass a link to the joystick. It's not a very good design, but I can work with this. As you all see, you can easily do this with unique pointers that used to move, so that was easy. I want to say, though, this whole recording and replaying feature was added by Olivier in a single day after we had the beers. I said, oh, wouldn't it be cool if you could record it and then we could do speed measurements? The day after that, he mails me, oh, I couldn't sleep, and I programmed that quickly. So, yeah, the code isn't perfect, but it doesn't, if you write it that quickly, right, it's a first pass. Sure. Okay. While I was inside that clock code has its own thread. And that's a bit of a weird design. But the guy works in hardware, and I see where he's coming from. He's used to having hardware timers that he can link to interrupts, and stuff happens at certain points in time. You can do the same thing with a thread. It's very nice. But if I modernize a thread, of course, what I'm going to do is use JThreads. The J, I have been told, is for Yosutis. Right? No? Apparently not. There was a pretty small change, improved the code and the readability a bit. So, okay. Since I was looking into that clock, and I was looking at the class, then I saw, there was a bit weird stuff happening. Finals missing, virtual missing, overrides missing. Things weren't const enough. So, again, changes. This changed in a lot of places, but all in all, it wasn't a lot of work. Class design quick wins involved making the destructor virtual. That was actually quite an important bug. Switching the virtual override to just overrides, that's a personal thing. Make the leaf classes final. Add missing overrides in Game Boy Clock. And then I also propagated const. I made something const and propagated it to the overrides. Okay. Again, when you're doing something like that, you're reading through the code, and you discover more small things that you think you can improve. I thought, oh, I'm gonna make some stuff const expr while I'm at it, right, and just touch upon it. Until now, I was just doing small things, right, getting my feet a bit wet. that bottle actually fell. So there was a check for the Indianness of the bits. Well, that's old school. I changed that with a static assert. Funny thing, you see the squiggly red lines under that? That's Visual Studio. It compiles, but the squigglies are there, and I cannot get them to go away. It's very annoying, but that's Visual Studio. Maybe it's not very good, but at least it's very expensive. And now, I'm going to do something. The most important part, if you're creating a Game Boy emulator, at least in the start, is the CPU. So you have to build a CPU. Has anybody gone to Matt's talk about Spectrum emulator on JavaScript? Yes, he was also complaining about so much instructions, and it is a huge pain. Yeah, let me show you. It's going to be easier. So. Yes. So, beware license, of course, all his files systematically. If the people who have gone to Matt's talk, he was describing how it's difficult to abstract things away, and you seem to have to write a function for every different opcode. Olivier found a way around this, and he grouped them. For instance, this instruction takes 3 parameters: an opcode, which is an 8-bit value, and 2 void pointers. And next one, also void pointers. Void pointers. This is the C bleeding through. I see void pointers everywhere, but that's very unsafe. And if you look at those functions, what do you do with these void pointers? You get the register and you cast it to the correct type to use. By the way, when you're using it, you're first casting whatever you had to a void pointer. That seemed very complicated and also very error prone. Just to give you an idea, I will scroll a bit to this file, and this all needs to be debugged and tested. Oh, by the way, if you go look at the projects, there's hundreds of test files. The test files were originally in JavaScript. There's also a Python file there that transforms them into C++. And if you activate the test, then it will compile in your CMake file the tests and run them for you, unless you are doing it through Visual Studio that crashes at some random point, because hundreds of test files, that's not something it does. I've tried different things and just could not get it to work. It starts the process, it compiles, and it just stops. No error message, no nothing. I've left it on overnight. The progress bar didn't move at all. Then what happens afterwards? Each opcode gets, by using bound with this, because of course it's a method, and then with a certain value. And look, there's a few of them. A few. And then there's also extended instructions, because of course there are, and that's another 256. So there's about 512 instructions. Yes, there are 512 because there are a few that do nothing, but these crash the CPU, which is a good design. I'm looking at you, 6502. Yes. If anybody ever implements the 6502, you have all the opcodes, you have nothing. You have nothing for special games that abuse the system. Anyway, so goal number 1. Oh, let me go back in present mode. I don't actually need my speaker note. This is way too annoying. Goal number 1, I'm going to remove all those void parameters. And you know how I use the output here with the little pluses and minuses, so I see progress bar. I will slightly have to adapt the font to show this. Yeah, that was great. So I did that, and I feel good about myself, at least for a little while. And then I started realizing, let me go back to, oh, PowerPoint, I hate you so much. Let me go back to my source code and look into the header file. No, look into my bindings, I'm sorry. The desk is really tiny if you want to use a mouse. I apologize. Okay. If you look at these bindings, maybe I should show them to you, yes. If you look at those bindings in your head, I am sending them to you right now. I wonder if that will work over YouTube as well. Okay. And of course, when you start refactoring, you go in like a ninja with your katana, changing stuff, not realizing what an idiot you are. I went through that whole thing once and then realized, because of course, not only did I have to change all these functions so they didn't take void pointers anymore and then remove all the castings, I also had to come into the bindings here and remove all those castings to void. So I have gone through this file already. I should have noticed all these null PTRs. What do these null PTRs mean? That parameter is not used. But then it's stupid to pass it to the function, right? So next phase, I thought, you know what? I am going to fix it. I'm going to fix it because I'm not a complete idiot. That's what I thought. Okay. I will remove all the unused parameter from opcode functions. That was actually quite a bit of work. And by the way, I know what many of you are thinking. That sounds like a very repetitive job that just requires a bit of intelligence. Isn't that something LLMs are great at? No, they suck at it. They are very good at telling you what you need to do, and you have to go through it and do it for them. They're your AI masters. The boring job, they will tell you, oh yeah, it's important that you remove these things. Can you do it for me? Well, you try and fuck it up. So you'll just be frustrated and cuss at it again and then fix it yourself. PhD level intelligence, I won't say it, but... Okay. So I did that by myself, might I add, not helped by AI. And all was well. All was well until I realized, you know what, bind? Who here still uses bind? Nobody uses bind. You still use bind?
It's in some of the code.
If you have a very old code base, maybe, but right? So then I thought, well, I've gone through the files twice now. Let's go through it a third time. Let's replace all these binds with lambdas, because that's going to be cleaner, and I have nothing else to do. Sleep is for the weak. Why else do we have coffee? So, just a small reminder. This is this file. with all these bindings in them. And I want to replace all these with lambdas. By that time, this file was, of course, already a bit changed. I could call it back, but I don't feel like it. You can just imagine how it was improved and how I would move further along with this. So, where was I? Oh yeah, I was being an idiot. Yeah. Because you'd think that by now I'd be smarter, but no. $1,200 lines that I had to change by hand. Well, by hand, not really. I know I don't need to tell most of you this, but I also will recycle these slides for my students because that's what we lazy teachers do. Regexes are the best. They will save you. So if I have this bind that's sitting on the top there and I want to change it to that, where did I do my clicker? I want to change it here after the, I want to change this, right, into this. Well, you can actually find and replace. You can do it with anything. Even Visual Studio supports regular expressions. I was pleasantly surprised, and it worked. You go through it step by step. I wouldn't dare do replace all. I'm stupid, but not that stupid. So I had to click replace and next every time. But I mean, compared to doing it by hand, that was a smooth ride. Of course, if you're very good at reading regular expressions, you will have noted that this one has a problem. If you call an instruction without parameters, it doesn't work. It binds something that doesn't have parameters, it doesn't work. So you need to write another one. Regular expressions are write only. You can just write them and you understand them while you write them, and then they're gone. Actually, large language models can be useful in helping write regular expressions. Not applying them, writing them. Okay. And now, Tom, is your nightmare over? Has the stupid stopped? Of course it hasn't. And I blame my students. I think it's rubbing off on me, right? So if I look into the extended instructions for the people who came to my first talk, the extended processor instructions on the processor and the Game Boy, it's a sharp, I forget the number for a second there, but the extended instructions are mostly about bit manipulation. And you see that little number there, that 4, that's 5, 6, and 7. There's also a bunch of zeros. You all know what it is. It's bit numbering, right? So you have some instructions that do something with a certain bit. So Olivier was smart. He wrote a general function, and when he binds it, he combines it with the number. But that's not very safe, right? Passing a value that's between 0 and 7. What do I need to do to fix that? What's the safest way? An enum, yes, an enum class. But I understand if you think the guy is stupid enough to do an enum first and then having to fix it. But no, I did it right the first time. So I could pass enums. I created an enum called bit. And also a little function, because in most of the functions where it's used, they use it to shift something and then use that as a mask. That was also a bunch of changes, but it wasn't too bad. And with that, I was done. Well, I wasn't done. When I decided I was going to give this talk, I can't go through everything, so I needed to choose what I would show and not. Let me show you the finished product. Finished, not completely finished. There's a bunch of other stuff I could still do. We'll discuss that in a bit. Let me... So what does this look like now? Look at it. These binds, how beautiful they have become. They're just lambdas, right? They're just lambda assignments. All of these functions take the correct amount of parameters. It's very user-friendly and readable, and that's on Olivier, right? You compose them with a limited set of functions that actually do something. Here you see, for instance, that it's using this shift function, which is const_expr. If you're wondering why didn't you make it const_eval, because you're combining that as sort of. I hesitated, but I might need a bit shift somewhere, and then I have a function. I mean, it gets compile time evaluated, so I'm pretty happy with it. Right. What else was I going to show you guys? Oh yeah, here you see, right, all these functions they are not void pointers anymore. I knew I was forgetting to show you something. One of the things that saved me is that Olivier, when he was creating this, he was incredibly systematic about stuff. So to avoid getting warnings for not using parameters, what do? If you're normal, you don't give the parameter a name. If you're my students, you use incorrectly, maybe unused at that point, but that's another discussion. So everywhere where he wasn't using something, he would comment away the name. And when he comments away the name, not only does he do that, but when it's called, when I see reg, oh, it was a register or it's a bit. Just on the name of the variable, you see he's not used to having this kind of expressiveness in his language, but he puts it in the name of the variable. So I could go, this helped with regular expressions to replace all the stuff. It was still a lot of work and a pain to compile. Anyway, but it compiles now. Let me prove it. Famous last words. And actually, that's actually something I hadn't shown you. Let me also show you this. It makes a UI application, but it also makes a little application called replay, which replays the game that we stored earlier without showing it. But it's not really faster than showing it. The Game Boy's graphics are so limited that showing these few pixels on the screen has no effect whatsoever. Well, it has an effect, but in the larger scale of things, it doesn't really have an impact. Okay. So are we there yet? Are you done fixing the code? Of course I'm not done fixing the code. Code is never done. But it's an old trope. What happens in an adventure story, some weirdo with a beard comes and leaves you finish the stuff on your own. There's plenty of stuff you can do with the GitLab I've provided you. For instance, there's no accept, things like no discard. There's still room for const_expr. The threading can still be improved. There's room for algorithms. What did I manage to do so far? The performance did not significantly increase, right? When I look at the little output, it's about 22 times faster than the original. Still good, right? If you want to train an AI on it, you can train it to play a day in an hour. That's already an improvement. There's still plenty of room for improvement. I have another Game Boy Emulator that I designed that's faster, but I will steal Olivier's idea how he combines these microcode functions to create his functions. That's actually genius of him. And I'm familiar with the code in the meanwhile. The code was also already compiled with modern compiler in C++ 17. Even if it was written in an old style, it was still, right? It was still compiled well, and it ran well. He actually got it running now on a Raspberry Pi 2040. That's a tiny microcontroller. So it's efficient code. This is interesting. Let me show this to everyone. My screen is not showing anything anymore, but I'll live with it. Yes. We've established I'm an idiot. Okay. So there's a tool called Lizard. There's a URL where you can get it. The total number of lines of code, and I was not trying to optimize for that, has gone from 4,000 to 3,500. I was not aiming for that. The number of functions has stayed the same. As I said, I have not tried changing the architecture. The Lizard tool has a certain built-in warning levels if he feels some files are too complicated or some of your functions are too long. I had 5 that were above that threshold. After changes, only 4 were above that threshold. Again, I was not aiming for this. I was just pleasantly surprised. The average number of lines per function went from 18.5 to 15. The cyclomatic complexity stayed the same. The warning rate per function lowered since the number of functions was the same. The warning rate per line of code also lowered. And remember, this was, and I cannot stress this enough, it wasn't modern C++, but this was good code to start with. And all I did was apply rules. Be more expressive, use the built-in things. I made no changes. For those of little faith, I actually stuck the results in there to see from what to what did we go, which functions are still problematic. Actually, it's interesting. The functions that are still a bit problematic, they actually reflect what part of the hardware are hardest to emulate. So that makes sense. I have a few conclusions. Good code can be written in bad languages. You can write good code in C++ or in any language, right? But by applying C++ to it, you can measurably improve your code. Measurably improve your code just by following rules. It's a free lunch. There's nothing you need to do than knowing what you are doing. Even if you don't do everything, I haven't done the whole thing yet, right? I haven't done enough context per stuff. I needed to be able to present it in a limited time. Another conclusion is if you work with strangers on projects, people you haven't met in decades, you learn new stuff, so that's interesting. Maybe preachy, but we as a community need to find a way to get more people on board with modern C++. Anybody writing books and trying to do that, you're the greatest of all time. I'm super happy that you do. Because there's a lot of good programs out there, and they are interested in this stuff. I'm sure I will show this to Olivier. He will be very enthusiastic. Remember, the guy didn't know a lot of C++, but he loves std functional, right? He used std function because he didn't want to use C-style function pointers. He used lambdas a lot, which he doesn't have in C. So people are interested in functions, but there's this perception that, oh, C++ is impossible. The beer license is awesome. Beer in general is awesome. And then a personal one, and since I have this forum, I want to share it. Being, let's say, fluffy, it's hard for me to use a computer on the plane. But I wanted to look at this code while on the plane, so I printed out the source code, something I haven't done in years. I read source code sometimes in books, but those are tiny examples. I was reading through it while we flew here. And I'm 100% convinced that I picked up more about the structure of the project doing it than when I use a computer. Because when I'm on a computer and I want to know what the function do, I right-click it, it opens some other file. I'm not reading the name of that file, and I'm reading what I need. And in my mind, it's just one flat space. But when you're on paper and you don't know, I have to turn to a certain page, and I learned to distinguish how the structure works. Maybe it's just me, maybe it's other people as well. I just wanted to share that. As a last thing, I want to thank my colleagues who make these travels possible. They're all great. Quickly, where am I on this picture? And Meres-Kun, who is also my colleague. We're here. That's it. Thank you. You were a terrific audience. If there are any questions, I have 3 minutes and 36 seconds left.
Did you find any bugs while you were working with this code? Worth mentioning. Bugs worth mentioning.
Good question. And I found some, but none that affected the gameplay on Tetris. But I found some that would break other games. Now, not just this. Also supports memory bank controllers 0 and 1, so it can play some other games, but there would be issues. It has to do with flipping bits, and I mean, you've seen how many functions there are. The odds of you writing that and not having a full coverage, also for the features it has to do stuff with sprites, the odds of that being perfect on the get-go, in my opinion, unless you are a god, is 0. That's why we need unit tests. But yeah, but it's a good question. But indeed, I have found some. Especially when I went to curly braces with everything, then some things came out of this. The curly braces stop narrowing conversions. Thank you. I'm sorry. They stopped narrowing conversion, and I found 2 or 3 places where it was a problem. I should have put it in the slides as well. If I give this talk again, I will put that in. and say somebody at CppCon, very smart, told me. Thank you. Any other questions? Yes?
Yes, I was just, you said that right now this is only supporting Tetris. Could you also have example, or is there any source code examples of games like other than Tetris?
Right now, it supports more than Tetris. I have seen it play, and I have tried myself. It plays the first Super Mario Land as well. Yeah, it's a special Super Mario Land, the first one, and something called Alley Cat. So there's a few games that it supports, but most games are more than 32 kilobytes, so they require the memory bank controller, and that's pretty new in there. So Mario works, Super Mario Land. Yes?
Yes, I was just wondering, could you use this as a kind of a test bench to create your own new Game Boy games?
You most definitely could, if they're not using advanced memory bank controllers, but there are other tools for that. The Game Boy is, I think, the easiest console to write an emulator for. So there's tens of them out there. Tens. Yeah, I dare not say hundreds. That seems like a lot. Tens. Maybe in the low hundreds. But you can find a lot of them who have very advanced building debugging features, will let you inspect VRAM and the state of sprites and whatnot. But you could, if you want to develop Game Boy games, writing your own emulator is the best way to understand how the hardware and the instructions work. There's no alternative to that, because you've built it yourself, right? But it could be usable. If you use it for that, feel free to, the GitLab is open, you can download it and use it. I would be very enthusiastic to hear if you've used it for something. Send me a mail. Thank you. Other questions? 29 seconds? No? Great stuff. Oh, yes? No? Thank you all.